Today we're breaking down how Burj Khalifa went from desert sand to the tallest building on Earth, step by step.
At 828 meters, the real fight wasn't just height, it was wind. Every record build starts with measurements, tests, and a plan you can actually build.
The goal was a new downtown anchor, a global landmark, and a magnet for investment and tourism.
Before you design anything, you design the ground it stands on.
A three-wing plan spreads loads and helps the tower fight twisting in the wind.
Next comes the hard part, foundations that can handle immense loads in desert conditions. You can't pour precision concrete on an imprecise site.
Now the tower moves from drawings into earthworks.
To spread loads, deep piles transfer weight into stronger layers below. To understand how this works, let's look at the load path. The weight is transferred down through the pile and into the soil. Think of piles as deep legs, and the raft as a giant shoe that spreads the load. Quality control isn't optional when the entire tower depends on this. In hot climates, temperature control can make or break strength.
Pour is a choreography. Place, vibrate, level, test, repeat.
With the base locked in, it's time for the climb. A concrete core rising like a factory line. Getting concrete that high means planning the mix, the timing, and the pump pressures. Quality control isn't optional when the entire tower depends on this. In hot climates, temperature control can make or break strength. With the base locked in, it's time for the climb. a concrete core rising like a factory line. Getting concrete that high means planning the mix, the timing, and the pump pressures.
Steel placement and embeds must be perfect before the next pour locks it in.
Watch the alignment, ease off the hydraulics.
Pins are in on the west.
East side clear. Lock them down and check the rails.
This is repetition with precision, hundreds of times.
The biggest challenge with these buttressed wings are the thermal setbacks we encounter during the pour.
Those stepbacks aren't just style, they break up wind vortices as the tower climbs.
High-strength concrete needs tight control, especially in heat. While the core climbs, the base levels build out in parallel.
Night pours can help manage temperature and keep progress moving.
Once the structure is racing upward, the next challenge is sealing it with a facade that survives sun, wind, and sand. The facade goes up like a puzzle, one precise panel at a time. As the skin closes, interior work can finally accelerate. The structure gets the headlines, but the systems are what make the tower livable.
In Dubai, cooling is a core system, not an accessory. Safety systems are tested long before anyone moves in. Elevators need millimeter alignment to run safely at extreme heights.
During construction, moving people and materials is a project inside the project.
Even the supply lines need constant inspection to prevent failures.
At this stage, the city can already see the finish line.
You don't guess how a megatall behaves, you measure it.
Building it is one thing, proving it safe and reliable is another. If you're enjoying these engineering breakdowns, subscribing and liking genuinely helps us keep making them.
The higher you gauge, the smaller the tolerances feel, and the bigger the consequences.
A megatall runs like a living system, and the BMS is the nervous system.
Now the tower stops looking like a job site and starts feeling like a building.
Clear wayfinding is part of safety, not decoration.
Before opening day, every route, barrier, and system gets rehearsed.
Flushing and balancing turn installed hardware into working infrastructure.
This phase is thousands of small checks that decide whether the building can open.
When it opens, the world sees the skyline differently overnight.
Keeping glass clean at this scale is an engineering routine of its own. A tower this tall never stops being monitored. You watch it, you maintain it, you learn from it.
Even wastewater streams can be captured and reused for landscaping.
In just a few years, the site transformed into a global icon.
The big wins were a wind-smart shape, disciplined concrete work, and obsessive quality control. The skin handles sun, dust, and glare while keeping views open.
It became a navigation point for the city, day and night.
From up here, you can see why engineers chase impossible ideas.
It's not about zero movement. It's about keeping motion within comfort limits.
The ultimate proof is boring. Day after day, it just works.
Records are built by planning minutes, not just months.
The next record won't just be taller, it'll need smarter construction, safer systems, and better efficiency.
Better mixes and tighter tolerances keep pushing the ceiling higher.
Burj Khalifa proves that records are built by repeating the basics flawlessly, thousands of times. See you in the next Mega Builds Build Breakdown.